So let me quickly go through the algorithm, Naive Bayes. So Naive Bayes algorithm is a supervised learning algorithm used for classification. It predicts class of the data using Bayes' theorem, assuming all features are conditionally independent in the given class. So Naive Bayes simply works on assumptions that each feature is independent of other feature. Just this is a simple assumption. There is no interaction between features, no correlation complexity is occurring between the features. That's why it is called the naive Bayes. Let us explore the example. Let me walk through an example. Movie review sentiment prediction, positive or negative, right? So I have some reviews here. Amazing movie, great acting, excellent story. So I have my model needs to predict the sentiment. So how will my model predict the sentiment given the reviews? What is the probability of given review is positive? So naive Bayes asks which class is more likely to observe this word. Okay. So the Bayes theorem states that probability of event A given event B has already occurred is given by probability of B given A into probability of A by probability of B. Here it simply means that when event A has already occurred, let's say we have 52 cards, and if we know the given card is a king, so why should I look at the 52 cards? Now my probability reduces to just 4 cards because the number of possible cards are just 4. Therefore, my sample size is reducing. Sample size was first at 54, now sample size is reducing. So my denominator changes. Here, the simple probability formula is P of A equals to total number of time A is occurred upon total number of time the event has occurred. Like, let's say, what is the probability of a given card is what we can say, a spade or whatever, a black card. So black card probability is 26 by 52. But if I know it is a black card, then the probability is the total probability out of the 52 cards. But if I know my card is a king, so now what is my updated probability? So from this, how much am I reducing the probability? So that is known as the conditional probability or the posterior probability. So which is the Bayes theorem. That is, so Bayes theorem is nothing, just a foundation of some linear algebra. Is given by probability of A intersect B is probability of B intersect A. We know that A intersect B or B intersect A is the same thing, but what A intersect B can also be written as A given B into probability of B, right? And B intersect A can be written as probability of B given A into probability of B. So if we take this probability of A here, we get probability of B given A as probability of A given B into probability of B by probability of A, which is the Bayes theorem. Nothing complex, too simple formula. Now the prior probability is before the evidence was observed. What was the prior probability? So probability of positive, assuming 70% are positive and 30% are negative reviews. So we have to observe the evidence that these words, amazing, great, excellent, and all the other words occurring in the positive class, and evidence of amazing, great, and excellent occurring in the negative class. So we build, because it will help determine the posterior probability. Now we have to build a co-occurrence matrix to calculate this, right? So the posterior probability will become positive given review. So review given positive into positive by given review, and same for negative. But we ignore the denominator as the denominator is same for both the classes. So while comparing it will be the same. So we just ignore it. So why naive Bayes is called naive? Because it assumes, instead of calculating probability of review given positive, it assumes each word is occurring independently in sentiment class. So instead of calculating the left hand side, it focuses on the right hand side, that is probability of excellent given positive, probability of great given positive, and probability of amazing given positives. It assumes that each of the given word is occurring independently in the given class. So that is the assumption naive Bayes is making. So how does it work? It computes the prior probability, it computes the probability of each word occurring in every class, and builds a co-occurrence matrix. So using this co-occurrence matrix, we can find the posterior probability. Before observing the evidence, words in this case, what was the probability, and after observing the words, what was the updated probability, that is posterior. So the highest posterior probability class is the prediction, obviously. So working example, let me see a working example to get more clarity. This is a probability. I have a review amazing movie. So I'm calculating a probability of positive given amazing movie, and is the probability of amazing given positive into probability of movie given positive into probability of positive. So I'm getting 0.0036, and probability of negative given amazing movie is probability of amazing given negative and probability of movie given negative. I'm getting 0.0018. As the posterior probability of positive class is higher, my prediction becomes a positive class. So here we have a problem in this scenario when a word is not occurring in the given class. Let's say I have a review containing fabulous movie, and the fabulous is not occurring in the negative class. So if I multiply the 0 with everything and 0 with anything, so everything becomes 0. If I multiply 0 with the probability of negative, the entire posterior probability goes to 0. So to avoid this, we use the Laplace smoothing, where we assume that each word is occurred at least once in every class. Occurred at least one in every class. So my probability would never be, the posterior probability will never be 0 for any class. It would be very small value. So this is the formula. We increase the count of the word by 1. Here so fabulous was 0, so count is increased to 1, and we divide the denominator by the total vocab size, as each word would be occurring at least once. So my vocab size was 1000 words, so I'm dividing by 1000. So the total words are my negative words, negative sentiment words in my negative class, plus the vocab size. So now there are some types of naive Bayes also. This was an example of a Bernoulli, where my target was binary class. We can also naive Bayes also has a multinomial naive Bayes, which can handle multi-class target, and if the target is a continuous variable, we call it a Gaussian naive Bayes. So what are the limitations and pros and cons of naive Bayes? Let me quickly read it out. Simple to train and understand. Yes, so the training is very simple. I have to just compute the co-occurrence matrix of each word occurring in each class, then the co-occurrence matrix can be used for the making the prediction. Next, the support, it supports high dimensional data, so it's very rare quality among the classifiers, because it, and it also works well for the text classification, like it is like previously spam classification was majorly done by the naive Bayes. Handles multi-class naturally. Yeah, so no number the matter of classes, it can handle every class naturally and calculate the posterior probability for each and every class, and we can find the highest probability class, posterior probability class. So some of the examples are email spam detection, sentiment analysis, language detection, document categorization, medical disease diagnosis. So given the symptoms, what disease I am suffering from, but the patient is suffering from, not I am suffering from, or the news categorization. There are some examples or applications of APIs. So there are some cons also. There is strong independence assumption is often unrealistic. So in the real world data, there will be features that are correlated, that are highly correlated and non-linear in nature. So naive Bayes assumes each and every feature is independent. So it cannot be used for majority, used for such data sets. So performance degrades when features are correlated, cannot model complex interaction between features. So this was naive Bayes. Thank you.